CNC inlays can be intimidating, but they're not magic, it's just a method. So in today's video, I'm gonna be showing you how to make this so you can get consistent, flawless inlays every single time. I'm gonna be walking through practical tips and different mistakes to avoid, from how to machine it, what bits to use, how to use those bits properly, all of the above, right? So this is gonna go in depth so you can make these beautiful inlays every single time on your CNC. Let's get right into it. So let's get started with the very first tip, and that's going to be when to use a straight flute inlay and when to use a V-Carve inlay. So a straight flute inlay, and I've done this on multiple different videos, but I just want to really reiterate this because it's important, is just when the wood fits into there and you can't get as much detail because you're limited by the diameter of the bit that cuts it out, right? So if you have a 1/4 inch diameter bit, then all of your corners have to be that 1/4 inch diameter radius and all of that good stuff. So the inlay we'll be doing today is the V-Carve inlay, which uses a V-bit, and when the piece fits in there, it snugs up on the corners, there's no gaps, and allows you to do really high detailed work. Now, the pieces we'll be using today is a maple male plug right here. This is gonna be 0.625 inches thick, and a female is gonna be a piece of walnut. That is our baseboard, and this is 1.7 inches thick. So as I'm taking this out of the plastic, what's important to note is that ingrain moves a lot, and so we like to wrap ours in plastic, because if not, it gets a little bit of moisture on one side, a little bit too much heat, it's gonna start cupping and warping, and so that's why we ship all these in plastic. But if you make your own, I highly recommend, like, if you sand them down, put them where air cannot get to any of the sides. That way they stay nice and flat. You need these to be really flat. If they're not really flat, then your inlay is gonna be a little bit messed up. And so what I'm gonna do is I'm just gonna check each side, or I can check each corner and see if it's the same height. 0.005, so it's just a smidge off, but I'm gonna go all the way to the other side now. 0.017. So to reiterate this difference, you know, I touched it off on my center point, and when I went over here, it was negative 0.05. Doesn't seem like a crazy difference. When I came over here, it was 0.17. which means collectively it's like a 0.023 difference. And what that is, that's gonna be bigger than our glue gap. And so if ours was to continue that inlay, then one of my sides, and I can't do the math right now, but one of my sides would be touching and have gaps on either side, kind of like that, and the other side is gonna have a bigger distance like that, right? Because it's already gonna be touching the sides and there's gonna be a bigger glue gap. And so only my middle would have been good, and that's what I originally touched off to. So real quick, I'll check this cutting board to see, you know, if it's flat. So the cutting board's flat, which means that 0.022 or 23 we're off is gonna be on the spoil board somewhere. So to check your spoil board, just take like a piece of material. I touched off over here, and I took that same piece of material and touched off on it over here, and there was that 0.023 difference. So I do know it is my spoil board on level, not the actual board itself. Now that's probably because I haven't surfaced my spoil board in a while, but that's always a good practice to kind of always do, is keep it nice and level. All right, let's surface it. All right, so after the spoil board, I did check, and now it is actually level. So whenever I jog the bit over here and touch off, and I jog the bit to the right side and touch off, it is level, right? So that is all good. So I'm gonna be doing the female first. It's gonna be a piece of walnut. That is our baseboard, and this is 1.7 inches thick. And the bits we're gonna be using today are a 3/16 upcut bit and a 30-degree V-bit, and of course we gotta use a V-bit because it is a V-Carve inlay. I do have these two bits as a set on CSC Workshop, so check them out. All right, here's what we're gonna be programming today. Just a simple split W with an established on the bottom. Nothing crazy here. I will be doing the female first, but I will not be using the V-Carve inlay toolpath that is on the Aspire 12 or 12.5. I'm just going to be doing it the old school way with the V-Carve method.
So all you do with the V-Carve method is select the things you want to engrave, set a flat depth of 1/4 inch because that's how deep we want it to go. Select our 30-degree V-bit, which we already have selected. There's my settings, running it at 90 inches a minute, 3% final pass step over. Those are the two important ones. So I'm going to select that one. And then I'm also using that 3/16 upcut as my clear out tool. Here it is. And here are my settings for that. So this one's pretty simple, and all I have to do is click calculate. So here is the 3/16 clear out doing its thing, and then we're gonna follow that up with the V-bit, and it's going to put in all of the other stuff. And so that clear out's just gonna help save some time there, and that V-bit's gonna come right back around just like that. So that is what we're about to cut out. Now, back to the CNC.
So we did all that clear out with a 3/16 upcut. If I was using an 1/8 inch upcut, I would have did it in 2 passes. What I like about the 3/16, it has the detail, like I said, but it can also do 1/4 inch depth at a time and no problem. I ran it at 100 inches a minute. So now it's time to take out our 3/16 bit, put in our 30-degree V-bit, and do the detail work of this female pocket. So the reason I'm using that 30-degree V-bit is because it gives me the angle I need, and if I went to like a 15-degree V-bit, that tip's gonna break off. And so we're using that 30-degree solid carbide 3-flute bit, and I'm able to do 1/4 inch pass depth like that at 90 inches a minute, and it's fine. Like, that's really cool. Now, over the course of this video, I know I'm gonna miss some different tips and tricks. So if you have done a ton of inlays, leave your tips and tricks in the comment below so everybody can learn from everybody, because I am definitely not the expert. I'm just giving what I know. And don't forget to like and subscribe. All right, so the female part is cut out, and that is this part of the process. A couple little side notes. Make sure your bits are always sharp, and try to use the same bit. So whenever we do the male part, make sure you're trying to use that same 30-degree V-bit or whatever V-bit you're using, and don't change angles at all. And the last tip is, if you get all these fuzzies in here, just get you a little simple stainless steel wire brush, go in there and clean out all of the fuzzies. So this one's done. I'm gonna get it cleaned up. We'll stick the male part on there, and that's where it gets a little bit tricky. So we have our male plug now, and if you do get one from us, I do them a little bit thicker than they should be. So typically you only need them like a 1/2 inch or 0.4. I do mine 0.62 for this very reason of you don't want your male part to be warping a lot, right? You don't want it to be warped at all. So I purposely make them a little bit thicker so you have a little less fluctuation when you're cutting. So whenever we do this male part, we're gonna use a 3/16 clear out first, and then we'll add additional hold downs before we do that V-bit to make sure it's perfectly flat. So keeping this male flat as possible is just as important as keeping that female exactly flat. And since I know my spoil board's good, I just measured my piece. It's exactly the same thickness on each side. We are good to go to run that male plug part. So I set the X, Y, and Z zero of that 3/16 bit. So before we start running it, I want to just reiterate what we're doing. We just made the female part. Now we're making the male plug, which is a flipped over version of what's about to go in there, and it's gonna go in there like this. Now, this glue gap on the bottom, which I'll explain whenever I'm programming, I call that your tolerance. And so whenever I set my Z0, if I'm just a little bit too deep or a little bit over, or this board's just a little bit warped, not only is this gonna let the glue puddle up, but this is gonna make me be human, right? And have a little bit of human air. And so as long as my Z0 and my board doesn't warp more than 0.02 inches, then my inlay is gonna sit really tight, right? And so let's just say, you know, you have a little bit more material in there, still good, right? So whenever I'm Z0ing this, I'm getting it pretty close using the paper method, right? Eyeballing it. But as long as I'm not crazy off, and this board is not crazy warped like that female board, whenever that spoil board wasn't good, you are good. So this is what we're cutting out to fit in there, and these are the different parameters that I'll be talking about whenever we start programming.
All right, let's program this male part, and there will be a few different tips in here, so I do encourage you to watch. So we're just gonna get the female part out of the way and then duplicate it, and now this is up and out of the way right here. The next thing we do is we typically just flip it to the right because we want to get the inverse, and so you always flip it and then you put a border around it outwards like so. The problem with doing this on this type of inlay is that it wastes all of this material. So with a male inlay, you do not have to do that. What I like to do with these is I'll actually break them down and group them into smaller groupings, and then you can actually put them in different places. So all I'm going to do is I'm just going to put these in here just like this, and as long as there's enough space for that V-bit and clear out bit to go on each side of it, you're good. And so we're just going to check with that clear out bit, which is a 3/16 bit, and it is good to cut on each side of it, but I want a little bit more room than that, so let me just make this a little bit bigger. And so I'm good there, not so good there. And so I'm just gonna kind of move this up and around. That looks good there. And now, since our male piece is this big, look how much room we just saved. So we can put it to one side or the other and actually save a ton of space. And then we're gonna take and do an outwards offset of a 1/2 inch, right? And now we can just go in, delete all this, and we have this beautiful outwards offset. And then I like to go in and put a nice big raster on this just so it cleans up all the corners. So quickly do this to all the corners. This is just something I do not have to do. It just looks prettier to me. So now with all that space being saved, you can use it for another male inlay that you do later and save you a lot of time and money. So to program this, here's the parameters we're going to be using. And once again, we're just using the V-Carve engraving toolpath. So we're going to select right here our material that we want to cut out. And I'm actually going to drag this to the bottom so I can get a clamp right there. And our start depth is going to be the distance that we want our plug to go into the material. So we want it to go in 0.23. So we're going to do our start depth at 0.23. And then our surface gap is going to be our flat depth. And so our flat depth needs to be 0.1. We are still using a 30-degree V-bit, and we're still using that 3/16 clear out bit. So all we do is calculate here. Now whenever we run that clear out bit, it's going to take off all of that material. And whenever we run the 30-degree V-bit, it's going to come in and clean everything up just like this. These pieces are fine because that clear out bit can get in between them because we checked that from earlier. Boom, 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 and boom. And that is just a few different pro tips on programming the male part.
So our 3/16 bit just got done clearing out, and there's a few reasons I use this one first. One, the one that's more likely to break is the 30-degree V-bit or whatever V-bit you're using, and so this one's going to remove all that material so these tips don't break on these bits. Second thing is it's clearing away all this material, and now I'm not necessarily worried about it moving a little bit because The V-bit is the one that does all those tight fitting areas, right? And the last thing is the biggest thing I see people not do, which causes bad inlays. So whenever you pocket something like this out and remove material, wood's natural tendency is to move and fluctuate, right? Because you have more surface area, there's surface tension you removed, all that good stuff. So when you're doing an inlay, I would be sure that after that clear out bit goes, come in and put like a screw in a couple of these spots, right? Because this stuff is going to move a little bit. And so because that clear out bit went already, I know that these spots are not gonna get hit by that 30-degree V-bit. It's going to make a world of difference on how tight all those inlays fit. 30-degree V-bit in, male part held down. Let's go. If you want anything you've seen in this video, whether it's the ingrain inlay kit or the inlay bit set, check it out on cscworkshop.com, and I'll also have it tagged right below this video. So just to reiterate what I talked about in the programming section, just because the female part has an inlay across the whole entire thing does not mean the male part has to have that as well. So because we nested it, we're able to add screws, hold everything down, and you saved a giant chunk of the male part that you can use on other projects. So hope that saves you some money, and those screws should save you your whole entire project. So now I'm gonna use the CNC to actually cut out all the pieces I need. You can use a scroll saw, jigsaw, bandsaw, whatever you want. So we got all of our pieces cut, the female and the male piece right here, and all of our little numbers on the bottom. And the next thing we're gonna do is the dry fit. And what we're looking for here is we're not gonna be able to tell really how much is sticking out of the bottom, but we'll know how far it goes in by this surface gap. And so as I put in this thing, one, you cross your fingers, hope it fits, hope you did everything right. And so we're good there. And then what I'm looking for here is that roughly 1/10 of an inch, right? Because that's what I programmed. And so this needs to be just a little bit less than the eighth of an inch. And it looks like it is without me putting too much pressure there. So we'll stick this in our handy dandy glue press right here. And I made this on another video. You can get the digital file on CIC Workshop as well. But it's a slap together inlay press for those of y'all who have not seen it yet. So basically, whenever we do the glue up, I'll put some Titebond 3 in there. You can use Titebond 2. There's a big debate about it. You know, Titebond 3 is waterproof and Titebond 2 is not, all this good stuff. They both work. So whenever you put the glue in there, make sure you get in every possible crack. And so real quick, I'm just gonna do a quick test, and I always like to do this on my inlays. I'll give it just a little bit of pressure, like so. And then I'll undo it, and I'll take this out, and I'll just kind of make sure nothing's kind of slipping. I'll make sure I have glue everywhere on all these letters. And then on the big one, what I'm looking for is that glue is hitting this flat part right here, and it is, which means I have enough glue, because if you remember, I have that glue gap at the bottom is 0.02 inches. And so if you don't put enough glue, it's not gonna hit that wood if you do have that 0.02 inch gap right there, right? Now, I made this clamp so you don't have to have a hydraulic press or all this crazy stuff, and it clamps really good. Just make sure to use some type of, you know, layering to even out that pressure. But now, we wait, come back tomorrow. All right, so our board has been clamped about 24 hours. You don't have to leave it clamped that long, but what I would say is that you're gonna see a little bit of warping due to the water-based glue that you're using, right? And so the board is gonna cup kind of like this, or this side's gonna bowl, right? And so if you were to finish it off at this point, what would happen is it would warp back once it dries out. So I recommend, and this is what most people do, they'll surface it off after that first initial glue up, and that way it'll let all that moisture evaporate, and if there's any trapped moisture inside of right here, it'll also evaporate. So we're just gonna stick it on the CNC, surface it off, wait another day, once again let it flatten out, maybe even a couple days depending on when it flattens out, and then we'll do the finish sanding and apply the oil. So let's stick it on the CNC and talk about some surfacing tips. Now whenever you're surfacing this material off, I do not recommend using a surfacing bit because the angle of the shear is going to cause a whole bunch of splinters. So use an upcut or a downcut bit. The one I'm using today is just a 1/4 inch upcut finisher. It's going to do a dang good job and not produce a lot of splinters. So how I'm surfacing this off, I'm just putting a big rectangle around the inlay, and then I'm doing a 0.01 cut depth. And so over here, I can just hover it above the wood a little bit and know that it's not going to go into it or anything like that. So just a simple pocket, raster pocket, going up and down like that and just hovering over that. So I'll set my Z depth a little bit above my material, and that way I know exactly where it's gonna cut. And this is gonna... Perfect review of that. Hold on real quick.
What was that?
So pro tip right here, make sure your clearance, see our clearance was set at 0.2 inches, and so it only picked up 0.2 inches over that Z height. So from where we set it here, it picked up 0.2 inches and drug across the inlay. Mistakes happen. Pro tip, make sure it picks up above the material so you don't get the bejesus scared out of you. And broken bits. So after you get it surfaced off, if it's a little bit warped, just wait a few days, it's going to flatten back out, and then you can either repeat that same surfacing just a little bit deeper to flatten out the board, send it through a drum sander, sand it down yourself. I don't really care, so I'm gonna wait, and then I'll send it through my wide belt, and next time you'll see it, it'll be all oiled up and finished. So the cutting board's all oiled up. These lines are so crisp, it's flawless. And as you saw, it's not that hard to do it on a CNC. There's just a lot of little nuances you kind of have to learn along the way. So I hope this video helped you and inspired you to make these beautiful boards. Check them out on CIC Workshop if you don't want to have to make your own. And as always, guys, remember, if you ain't cutting it close, you ain't cutting it right.